Hi all, thanks for joining my talk, Widgets Gone Wild, a talk where we will discuss widgets, post messages and cross-site scripting. My name is René de Sain, but you might know me as renniepak. I've been a full-time bug bounty hunter for the past 3 years, and the TLDR of my introduction is I really like cross-site scripting, about this much. So we're gonna discuss widgets, and for those that are unfamiliar with what a widget is typically a third-party component that allows you to easily add some functionality to your own website. Like for example, here we have a weather forecast added to our website. But it can be other things as well, like for example adding your social media feed to your website, or another example would be adding a chat widget that allows you to have a chat with the visitors on your website. And when we look at, for example, these chat widgets, you'll see that they are used a lot. When you look at a site like BuildWith, which is a site that keeps track of technology used on the internet, the top 1 million websites, about 200,000 of them use some kind of chat widget. And when we look at the vendors who are offering these widgets, you'll see that there are a lot of them out there. And so some of these widgets are fairly simple, like the weather forecast widget that we saw. But you can imagine that these chat widgets are a bit more complex. They might want to show some HTML on your website that displays a chat message. Or they might want to offer some functionality that allows you to redirect a visitor on your website to a support page. But because these widgets are often hosted on a third-party website that has a different domain, a different origin than your own domain, they can't directly interact with your website because that is blocked by the same origin policy, a default browser protection that is especially introduced to prevent this kind of functionality. So to overcome this problem, basically, a lot of widgets use post messages. And post messages is another browser feature that is especially introduced to overcome this origin difference. And instead of, well, pointing you to the specs and let you figure it out on yourself, I've created a series of demos that will get you introduced into post messages. And we'll also discuss how developers should verify if a message comes from a specific origin and how that could lead to cross-site scripting. So here is our demo page. This is our page. The domain is 0-a.nl, and we have an iframe that is on cm2.tel, so 2 different origins. We have a sender. The sender is a bit of code that gets a reference to the iframe and allows us to send a post message to it. And on the receiving end, we have a event listener listening for messages, and it will handle the event object in a specific way. We'll look into that in a bit. So what we can do here, for example, is say hi Naham and click send, and you'll see that our message, our chat message, is displayed on the cm2.tel origin. So let's have a look a bit at origins. The funny thing about post messages, especially as a bug bounty hunter, is that there's only an origin check, you could say, at the sender half of the equation. So here you'll see we've set origin is a wildcard basically, which means it will be sent to any window within the DOM. But we could also set a specific origin, in this case cm2.tel, Maybe we'll add something else here. Test. Send it again, and you see it again is received. But when we specify another origin, we only want to send it to cm3.tel, for example, it won't be received by our origin cm2.tel. So let's ignore that for now. That's for the rest of the presentation, that's not really our concern. We are more concerned about origin checks in the receiving end. Because when we look at the message object that is received at cm2.tel, I have a button created that shows the last received event. You'll see it contains a data attribute, which contains our message, and it contains the origin it is received from. In this case, 0-a.nl. I've left some stuff out for demo purposes. Normally this event object is a bit bigger, but for demo purposes I've kept it a bit compact. Now let's look at our JavaScript code that is receiving our post message. So it receives this event, it gets the data out of it, being hi NahamCon test. It concatenates it to a bit of HTML and appends that HTML to our website. Now if you are into XSS, you will spot a DOM XSS opportunity here, because concatenating user-supplied inputs and setting it to inner HTML is a recipe for DOM XSS. So now imagine that cm2.tel is the site we want to target for our XSS, and 0-a.nl is my website, the Bug Bounty Hunter's website. As we've seen, there is no check in here that checks what origin the message that is handled should originate from. So basically any website that can get a reference to this window, for example by iframing it like we've done here, can send a message and it will happily process it. Also if that message is an XSS payload. So let's try that for a sec. We send our classic image source on error alert, and when it is sent and received, you'll see that cm2.tel triggers an alert. So we've successfully exploited our cross-site scripting here. Now you might think that, well, a typical post message listener wouldn't be this unsafe, right? This is a demo for just this talk, and you wouldn't see this in actual websites. Well, I'd argue the opposite is more true. I see this happening a lot out there. Developers using post messages are solely focused on the functionality and totally forget to implement some kind of origin check. So let's dive into an example that does implement an origin check, but as you'll see in the other demos, it often goes wrong somewhere. So again, we have a similar example. We have our post message sender, our post message receiver, and this post message receiver checks that the event origin starts with cm2.tel, which sounds plausible. We can also try it because now we are on the origin 0-a.nl. So if we send something, hi there, we see block message from untrusted origin. And if we look at the code, that is the option that is triggered when the event origin doesn't match cm2.tel. And again, we can look at the event, how it is received. And indeed, our origin doesn't start with cm2.tel. Now, how to bypass this? Well, it's actually fairly easy. Here I created a subdomain, cm2.telecom.0-a.nl. And if I send a message here, it is received by our vulnerable post message receiver or listener. And again, when we look at our event details, when we look at our origin indeed starts with cm2.tel. Not to mention that it's a whole different subdomain of a website controlled by me, but we pass the origin check and again can trigger our XSS. This is also a common mistake you'll encounter in the wild. Let's move on. So this developer has tried to be a bit more thorough. It created a regex to validate if a postMessage comes from a subdomain of cm2.tel or cm2.tel itself. So let's try it again. Send our message, and indeed it doesn't work for us. Again, our origin does not match this regex, and therefore the error message is displayed. Now let's dive into this regex a bit. If you are unfamiliar with regex, this might go over your head a bit, but let's see. Our regex to start with HTTP, potentially HTTPS : then any character A to Z 0 to 9 dash or dot, and then .cm2.tel. Now, some of you that are familiar with regex will see that I tricked you a bit, because just a dot doesn't mean a dot in regex. It means any character. If you want to specify an actual dot, you should escape it with a slash. So if this can be any character, we can also abuse that. So I've created a domain called hackercm2.tel. And when I send a message here, it is received. The error message is not triggered. And when we look at the origin it's received from and match it to the regex, let's start from the back. So tel, yes, we have tel. Any character, this dot means any character. Well, any character in our case is a dot. cm2 matches. Again, any character is an R in our case. And then we can have A to Z any amount of times. And in our case, this is hacke. So again, we matched the origin check and we can abuse it for our cross-site scripting payloads. So that's a cool one. Now, another cool example is the following. In this case, we're just looking at the receiver at cm2.tel. And when we check the origin check, it's like checking for a static domain. So it checks whether the origin actually is https 0-a.nl. Now let's imagine we don't control 0-a.nl. It's not our website, it's a third-party website. So you could say, well, we're lost here, right? We can't control, we can't host a POC on a third-party website, so this is not bypassable. Well, you might be wrong, and I've seen this in a few cases in the wild. For example, when you have an XSS on that third party. So here's the third party, 0-a.nl. And there's a classic reflected cross-site scripting on there. So let's try it for ourselves. Let's say hi. And when you look closely, you'll see that the hi is strike through. And so when you can also try our typical XSS payload. And indeed, an XSS triggers on 0-a.nl, the third-party website. But let's say the third party doesn't have a bug bounty program. So this XSS is fairly useless for us as a bug bounty hunter. We want to get DOM XSS through that postMessage listener on cm2.tel. So what we can do, we can use this reflected cross-site scripting on 0-a.nl, which is an origin that is accepted by our vulnerable postMessage listener receiver. And we can use that to send a post message to the website we actually want to target. So I've prepared the full POC here. You can check out the code a bit. But what we've actually done is use similar code as in the previous demos. We inject an iframe to cm2.tel, and using our reflected XSS on 0-a.nl, we send a post message with the correct 0-a.nl origin to our vulnerable website. Another interesting example is this one. I don't have the demo to show it for you, but it's an example you'll also encounter in the wild, actually. So in this case, the origin check has an array of trusted hosts. So let's imagine 0-a.nl is a third party we don't control. Google.com, obviously, we don't control. We can't host our post message POC there. But there's also a domain in the list, testdomain.notregistered.net, which is a domain that the developer added to the list for testing purposes. It never actually got registered, or the domain registration got expired, but they forgot to delete it from the array. So in this case, what you'll do is you'll register the domain for yourself and host your post message XSS POC there. Easy. So some tools that you can use to do this kind of research. So a really big one for me is the post message tracker by Franz Rosen, which is a Chrome extension that you can install, and it will show a pop-up with all the post message listeners on the page, also for embedded pages, so for frames within frames, etc. So it's a really handy, fast way to see what post message listeners are there, and to immediately be able to inspect the code that is triggered with it. Another great tool is DOM Invader by Portswigger. It's a tool that is that comes with the embedded browser within Burp Suite. And what's really handy with DOM Invader is that it allows you to set your own origins. So you can create a post message POC and set or spoof basically your own origin. So that allows you to quickly test hypotheses with what origin could bypass certain restrictions. Another thing that I would really urge you to learn is use the Chrome DevTools. I've linked a great starter video by Reconless about the Chrome DevTools, but I would also urge you to just look into it a bit for yourself. So for example, here we have Chrome. I've opened one of the post message receiver pages, and when you inspect the page, go to the sources tab and check out the global listeners drop down here and select messages. You'll see a list, in this case it's only one, of all the event listeners, in this case message listeners. And when you click it, it will link to the code, and you can set breakpoints and interact with it basically that way. So in this case I could send my own post message and step through the code that way. That's it for me. Thank you very much for joining my talk. Thank you NahamCon for having me. I hope you learned something. Thank you very much. See you all soon. Bye.